Hey, has the SQL group done anything about getting on Mixer or anything?
We told them it's possible.
Yeah, Rich has at least 3 more nights a month that his wife wants him to stay away, so. Does she have like a little wall calendar or something?
Mics are on, by the way.
Oh! Oh, careful.
Bill from the Philly.net group caught on a hot mic.
Yeah. You did.
You did.
The second time in a month.
No, I'm pretty loud.
I think I struck a chord somehow.
Organized. Whether the shit exists.
Yeah, I do. Because we gotta shut the room mics off.
Okay.
Just when everybody typing it wants it being too
I'll
much.
lapel it up.
Yes.
Check.
Always, and we will try to repeat questions so that way it goes back through the stream. There's what, 10-second lag?
Okay.
I was going to ignore you for at least 30 seconds. Yeah.
It is now.
Turn it off.
All right, I'm up. I got the mic on. We're streaming. Are we recording? All right. That sounds good. Okay, cool. All right, we have a decent group now. So welcome everybody. This is the June meeting of the Philly Azure meetup group. Thanks for coming out. We're gonna make this quick because it's already 6:12 and we have 2 awesome presentations tonight. One on ARM templates and one on Databricks. So I'm looking forward to both of that. If during the meeting, if you have questions, just raise your hand and they will call on you. And if we need a mic, we can. Otherwise, if the presenters can just repeat back into their mics, that'll be much easier for the live streams. Just so everybody's aware, we are live streaming this on YouTube, Mixer, and Twitch, and we are recording, and it will be posted on YouTube directly after the meeting. So awesome if you need to go back and reference something, but also because we need to tell you that we are recording all of this and then posting it to the internet. So looks good from here. All right. So I'll give you some quick announcements that we always do at the beginning of the meeting. And then, like I said, we'll have Ned Belvance, Microsoft MVP from Anexinet, also also the sponsor. Thank you. And then Matt Whitman from Microsoft talking about Azure Databricks. Announcements. Couple news items, just for everybody's aware. One, if you don't, I've talked about this before, if you don't see these coming out every month or every week, however often they come out, check these out. This is basically last week in Azure, and it's been rebranded as Azure.source. The latest one to come out is volume 35. It's by Rob Karen of Microsoft. He basically collates a ton of links that come out on the Azure blog into a nice little blog post that goes through the highlights of it. So that this is the latest one. Check it out. The other big news, I think AKS went GA today. Did anyone else hear that? 2 people. All right. So the other MVP in the room, the Microsoft person, both confirmed. AKS went GA. So please check that out as well. I will forego the rest of those. The rest of the announcements will just be right there in the source. So check that out on your own time. I briefly want to say these are some upcoming events that we have going on. Next month is going to be 7/10 right here. Tech 365 May is not happening. Sorry, I had the slide up before we found that out. But Tech Bash is. And then in the fall, I'm working on a joint meetup between us and the AWS group from here to try to do a combo. And actually, we're looking to get Google Cloud as well. We're trying to do a triple meetup of the groups that are all around the area to talk cloud providers and give everyone's going to be friendly, and it's going to be a nice cross talk about the services of all 3 of the major cloud providers in the space. This is in its infancy right now, but I at least wanted to throw it out there in case that was something you wanted to see. It is coming up. So, of course, we must thank our sponsor, Anexanet, who Ned is with, and we'll say a few words about, I'm sure briefly, when it's his turn.
Yeah,
when it's your turn, you can come up
my
with
turn,
that.
I'll talk,
You'll be
yeah.
first as well. So thank you to them again for sponsoring, and that's who had the food, and we really, really, really appreciate that. Also, Ned is going to be the first presenter, as we've said before, followed by Matt Whitman up front on Azure Databricks. And that is it. It is 6:15, so we are going to hop right into the first presentation.
Thank you, Tim. And we'll do the fun media swap, and everything is going to go swimmingly, right? Nothing is going to break. My laptop is not going to crash for the 3rd time today. Yeah, if you were prompted to install a Windows Update today, you might want to wait on that. Just saying, not from personal experience or anything.
We both know better.
At least I didn't run it while the presentation was going. Not that I would ever do that. But. All right, let's see if this actually, oh, there we go. All right. Excellent. All right, so to get started, good evening, everyone. My name is Ned Bellavance. I am Microsoft MVP in Cloud and Data Center Management, specializing around Azure Stack. I'm not talking about Azure Stack today, but if you want to talk about Azure Stack, you can hit me up after the presentation. I work for a company called Anexanet, where I'm the Director of Cloud Solutions there. So if you are curious about what Anexanet does, we're a consulting company, mostly in the Philly metro area. We do digital applications, we do analytics, and we do cloud infrastructure and on-prem infrastructure. So if you want to talk about that, we can talk about that after the meeting as well. You can always find me on Twitter, Ned1313. I do have a website called nedinthecloud.com, so that's hopefully pretty easy to remember. And all the examples I'm going to be going through today are on my GitHub. I have a repo called ARM template azug. So if you want to, go through the examples later or reference them in some way, you can get them on GitHub. It's nothing's proprietary or hidden. So just out of curiosity, how many people here are familiar with Azure Resource Manager templates, use them, love them? I know Rich does. Okay, so we got a couple of people that are familiar with the concept and probably have used it a few times. So what I wanted to run through quickly before we get into the actual templates is Azure Resource Manager, which is what you're actually interacting with when you want to submit a template for deployment. So what does that deployment model look like? How does that work? And why are we talking about templates at all to begin with? So then we'll shift into what's the deployment process when I have a template. How do I actually submit that to Azure Resource Manager, or we'll just call it ARM, for deployment. And then finally, we'll dive into what are the actual components of the template. All right, so maybe you've seen this graphic before. I definitely got it from the Microsoft website, so I hope they don't mind. This is sort of the overall architecture of how Azure Resource Manager works. So the actual Azure Resource Manager is in the middle right here, where it says Resource Manager. Sitting on top of that is the Azure Resource Manager API, and that's the API that you interact with when you want to submit a deployment or get information out of Azure. And some of the tools that you can use to do that, you can use the portal. So we just log into the portal and it works exactly like you would expect it to. You can go through the command line. So there's the Azure CLI, and there's also PowerShell modules for Azure, which is what I'm going to be using today. Or you can use Visual Studio, either the full-blown Visual Studio or Visual Studio Code, to interact with the Resource Manager API. When you send a request to the Manager API, generally speaking, you're requesting that resources be created. So how does the Resource Manager go about creating those resources? So it doesn't actually do any of that work itself. What it does is it has a contract with a bunch of resource providers that make up Azure. So all these different services live down here. So like the storage service, the compute service, the app service, which I think is actually called websites. All of those live below the resource provider contract. And when the resource manager gets a request to create something, it interprets that request and then sends a request through another API to the REST endpoint of these providers. And excuse me, the providers do the actual work of creating that resource. So when you say, hey, Azure, I need a new storage account, and I'm going to send you information about that storage account, that request goes through Resource Manager. Resource Manager validates some of the information in there, making sure you're not sending garbage in, and then it sends the request down to the storage account right here. Storage account creates that storage account wherever you said you wanted that storage account created, and then reports back up to Resource Manager and to you to let you know that it was successful in that whole process. Yes?
How about something like an API management service?
An API management service. Good question. And the answer is, I'm not sure exactly what providers make up the API service, so it's probably multiple. So what I would imagine, and I probably want to confirm this, and maybe Rich will nod his head vigorously, what I imagine happens is that the resource manager takes that request and says, okay, this is actually 3 different providers that are involved here, so I'm going to orchestrate standing that all up for you. And then when they're done their work, I'll let you know, and you'll have your API gateway or whatever it is. So that's best guess, but I trust would confirm. So that's the overall model which we're leveraging when we're sending a template to Azure to deploy something. As far as the deployment lifecycle goes for when you're creating templates, the first step is to author the template, and you don't have to start from scratch. Microsoft has been very kind to post a whole bunch of Azure quick start templates on GitHub that have a lot of very common scenarios in them, and just an example of how you might deploy something. So a basic VNet, a basic VM, setting up a SQL database as a service. You can start with that template and then kind of run from there. The next portion is to validate that template before you fully deploy it. So there is a command in PowerShell called test Azure RM resource group deployment that will validate your template before it actually goes through the deployment process. There's the same way you can do in CLI and through the portal. Then you actually deploy the template, and that's submitting it to Resource Manager to create the resources. And then finally, you can monitor the status of that deployment until the deployment completes. If you want to make a change to your deployment, so let's say you had a virtual network with 2 subnets and you wanted to add a 3rd subnet, you would author another subnet in that template and then go through the submission process again. And rather than tearing down and recreating the entire virtual network, Azure Resource Manager is smart enough to go, oh, you're just adding a subnet. I will make that one incremental change, and I won't break anything else that's part of your deployment. At least you would hope. In terms of deployment options, I kind of ran through this quickly. You can use Azure PowerShell. You can directly interact with the REST API if you're feeling lucky. You can use the Azure CLI if you're more of a Linux background, you like that feel and format for it. Or you can log directly into the portal So before I get into this, I just want to go through a quick example of what that portal experience looks like if anybody's unfamiliar. So let me drag this over. If I can figure out where that screen, there we go. Okay. Figure out where my mouse is. No, log me right in. Okay, that's nice. So when you're creating a new resource in your portal, you would simply create a new resource. I might want to create a Windows Server. Oh, that's going to take a while. Let's just do a storage account. I can give it a name. Is a test. Go through all the various settings. So what it's actually doing here is it has a template that it uses to generate all of this stuff. And so once I fill out all the fields, I can go to automation options. And when I go to that, it shows me the template and parameters that it's actually going to use to submit to the ARM engine to create this resource for me. So I don't necessarily, I could take this as an example template and use that to build out a deployment instead. The separation here is you've got the template, and then you have the parameters that you're submitting to the template. So when I was filling out the boxes or accepting the defaults that are in there, I was actually specifying values. So there's the value of the name of the storage account that I was creating. It defaulted to this type of storage account, etc. So that's the experience when you're doing it through the portal. So let's go back to the slideshow. Okay, there we go. Okay. So to take you briefly through how you would do it through a PowerShell deployment process, the first is to log into Azure using the add Azure RM account. There is an alias called login-Azure RM account. There's a big fight over the fact that login is not an accepted verb in PowerShell. So they changed the official one to add, but you can still use login. It's supported. The region, I specify a region just to make my life easier up front and store that in a variable. Deployments live within a resource group. So not every component of your deployment has to live within a resource group in Azure. Is everyone familiar with resource groups in Azure? I hope anybody have a question about that? No, we're good. Okay. So when you create a deployment, you're going to tell it what resource group holds that deployment. The actual resources being deployed could go in that resource group, or they could go in multiple other resource groups, but the deployment itself has to have a home in a resource group. So I create a resource group up front, test the deployment. In this particular case, if you look at the command, I'm using the -template file. So I'm passing it a local file that has my template values in it. And then for the parameters, I'm passing it this template parameter file. So I've got a separate file that's got all of my parameter values in it. If that test comes back clean, then I can run the actual deployment. So the command for that is new Azure RM resource group deployment, which when I'm using that in the command line, I create a really short alias for, because that's a lot to type out. I have to, again, reference what resource group I am deploying that to. I have to give the deployment a name, and then tell it what template I'm using and what parameter files I'm using. And then after the deployment is complete, I can always do the get Azure RM resource group deployment to get any information about that deployment. So let's run through an actual demonstration of that. Pull up if I can find my mouse. Is it up? Is it? Ah, there we go. It's exactly where I wouldn't expect it to be. Okay, so we'll just run through some of these commands real quick. It's the same ones I was just talking about. So we'll go through the login process. I don't know if I've ever used connect as the verb. The question is, as far as commands go, I'm using add Azure RM account, and it used to be most people would use login. And a gentleman was asking about connect-Azure RM account. I don't know if that was ever a valid verb for that. I'm sure there was a debate about it at some point. So I'm just logging in on my other screen, and I should get a prompt on my phone because I enabled two-factor authentication like a good good, responsible citizen. Go. All right. So once that approves, the subscription I want to use should be selected by default. So right, good, it's using my MAS subscription. So I am going to go ahead and just define some variables for my resource group and location, and then we will create this resource group. Go. That's big enough everybody can see, right? Looks like it's pretty big. Okay. Like I said, the command for new deployments is really long. So if you want, you can use the new alias command to alias that to something a lot shorter like ASD. Because I'm going to be copying and pasting, I'm not going to do that, but I am lazy, so I like to use aliases. So we're going to go through the very first template deployment. I am going to deploy this template called Hello World. It's a very simple example. And it sort of gets into what exists within the template itself. So in this case, the only thing that I am asking the template to do is to hand me back an output. And this output has a value of hello world, and the type of the output is string. And that is all I'm asking for that template to do. So its interaction with Azure Resource Manager is going to be pretty minimal. So if I can highlight this successfully. Okay, so I'm doing new Azure resource group deployment. The name is Hello World. The resource group is the one I just created. And then I'm handing it the template file. And because it doesn't require any parameters, I don't have to specify a parameter file or a parameter set. So that'll take a second because it actually is checking in with ARM and validating the template. And there we go. It has returned my outputs of just a string that says hello world. So, very simple example for that. Let's go back to here. So this is the template format. The very first thing is the schema, which as far as I know has not changed since 2015. So you can specify what schema you're using. If they update the schema in any large way, then you're going to want to update that date at some point. Content version is an optional portion. Oh, and before I forget, the template format is in JSON. Everybody loves JSON, right? We're all big thumbs up, huge fans, right? You don't have to love it. Two thumbs. I like JSON for machines. I don't love it for people because you miss one squiggly bracket and you're troubleshooting for 15 minutes. But it is what it is, right? YAML support has been rumored for quite some time, and maybe at some point it'll happen. But for right now, it's JSON or nothing. The content version is an optional portion. You can use that for versioning your templates, so you can put a value in there. This is like 0.1 version of my template. The parameters are values that you are going to pass to the template at runtime. And those parameters can have default values. The key things about parameters is the parameter at the very least has to have a object type, whether that's string or int or something else, and it has to have a name that you're giving the parameter. And that's it. Everything else is optional, but there are some pretty cool fields in there, and we'll get to that in an example. Variables are values that you construct within the template. So you can take parameters and then other information in the template and put that together to form a value that you might use multiple times throughout the course of the template. Bless you. Functions is a relatively new one, and I didn't even know about this till I started putting this together. I'm not sure when they introduced this. Functions is pretty cool. You can create your own functions for generating values within the template, and then those functions run at template runtime to generate what's usually more complicated objects within your templates. Resources is the meat of the template. So resources is where you define a list of resources that you want to deploy in Azure. So that's kind of usually the meatiest part of any template is all the different resources that you're creating. And then the very last thing is outputs. And that's any information that you want the deployment to output to either the command line or have available to something else that's calling it. So in most of the examples I'm going to be using, we're just going to be seeing the output that comes out and hits you right on the screen. But if you are in a situation where you had multiple templates and one's calling the other and needs information when the deployment's done, this is your way of passing that information back to the template that called it. It can look at the outputs and query the value for a particular output. So those are all the different template formats, and I want to get to functions just yet. We'll talk a little more in depth about some of these various things. So what was next in parameters? So like I mentioned, when it comes to parameters, here we go. We can kind of take a look at this. So here's the template that's all about parameters. And so the first parameter that I'm defining is a string parameter. And so the key here is string param. That's the name of my parameter. The type that I'm defining is string, and if I wanted to stop there, that is all I have to tell it about the parameter. But I don't want to stop there. I want to give it more. So I'm setting a default value that by default, if the person calling the template doesn't specify anything, then it's going to have the value of option 1. I also want to sort of put some guardrails around the person using this template. So I only want them to be able to submit option 1, 2, or 3 as allowed values. If any other value gets submitted there, the template stops right there during the validation stage. The metadata is a good place to put in descriptions. You're not always the one who's going to be launching your templates. Somebody else might be launching them. JSON does not support comments, so this is your opportunity to put comments in your template and explain what that parameter is for and how it should be used. I'm going to skip over the next one just for the sake of time. Another object type is the int. So you can specify int as a parameter type and set a default value and give it a list of allowed values. Object parameter is interesting. So you can create your own custom objects in here. So what I've actually done is I have given it a default value, and it's 2 key pairs here. One name, an object, and location, Earth. So if I want to reference values within that object, I can give the object name, which is object param in this case, and then use dot notation to get to the values below. So object param dot name would return the value and object if I stuck with the default values. Array is another type that you can use for parameters, and it doesn't have to be all the same data type within the parameter. So I'm mixing. In this array example, I am mixing strings and ints, and the template format is absolutely okay with that. And then another value that is fairly commonly used is the Boolean type. There is conditional logic that was introduced in templates about 1.5 years ago. It got around a lot of issues that people had deploying templates before. So Boolean values are one way that you can use the conditional logic that's within it. So let's go ahead and we're going to run the parameter demo. Without specifying any parameter values, so it's just going to use all the default values. If I run that, and the wireless gods are with me, we will get an output in a moment. Well, that's, oh, there we go, yay. So you can see here are all the outputs. So I've asked for an output of every parameter that was in there. The string param gave me back option 1. The int parameter gave me back 1, and then this custom object, which is a really cool thing that you can build, has the 2 key value pairs in there that you can reference individually. Okay. If you want to submit your own parameters, you can do that using a parameter file. The parameter file is also in JSON, or you can create, if you're using PowerShell, you can create a hash table that has the key value pairs in it and use that to submit back to the deployment. So in this case, I am setting the string param to my string, the int param to 4, and the array param to 1, 2, 3, 4. So let me just create that real quick. And now I'm going to scroll way off the screen. Try that again. Sometimes I should bring a mouse. Where was I? No, I'm good. I've got it. This is where it was. I'll blame it on the Windows update. So if I run the test, this should actually fail for me. And the reason it's going to fail for me is because the string param my allowed values were option 1, 2, and 3, and I didn't give that as an option. So what it's telling me is that the deployment template validation failed. My string is not a valid option. Please use one of the valid options. So you'll notice the command I ran was not new Azure Resource Group Deployment. It was test Azure RM Resource Group Deployment. So that's one way to check your parameters before you submit the template and have to wait the additional time for ARM to kick back and say, nope, you messed up somewhere. If I do submit it, it'll come back with a whole field of red. So rather than do that, we'll recreate our template parameters using valid options this time. And as you can see, the command here, one of the things that I'm passing is the dash template parameter object, and then giving it the template hash table, parameter hash table that I just created. So if I run that, that'll take a few seconds to run, and it should return back the proper values this time around. There we go. Okay, so now my string is now option 2, my int is 3, and my array is 1, 2, 3, 4. So I think that was it for that. Variables, so like I said before, the point of variables is to take a set of existing values, whether those are parameter values or values that you can pull from other resources, and create a common value that you're going to use throughout the portion of your template. So for this one, I've got 2 parameters that I set up. One is a default string Azure rules and a loop count of 3. So this gets into one of the things where you can create loops or copy loops within your template. So going into the variables section, we've got a few different variables in here. One is the basic variable. And so this actually gets into the functions that exist within the Azure Resource Manager template. So it does have functions, and one of them is concatenation. So concat will take any number of arguments within it and try to concatenate those together into a single string. So in this case, I'm creating a basic variable, and I want to concatenate the parameters, the parameter seed name. So I'm using the parameters function to get the value stored in seed name, and I'm concatenating it with this my basic variable. If you wanted to structure a more complex variable, something that you could call various values out of, in that case, I can give it a name, and in that case, I'm using concat and parameters to call it seed name dash my complex variable. And then I'm also storing a list in here of 1, 2, and 3. So I'm storing an array in there. To kind of illustrate the copy loops, there's 2 different ways you can do the copy loop. And this gets a little confusing, but I did want to bring it up because it's kind of cool. You can create a variable and then run a copy loop inside of it to return a whole bunch of values within that single variable. Or you can call copy first and create a whole bunch of variables that are all separate, and it actually hands back an array of those variables, and then you can iterate through that array. So it's 2 different ways you can use the copy and variables to create an iterative type value system. That's probably easier if I run this so you can kind of see how that works. So we'll try that. F8. And assuming everything works properly. While that's running, I didn't really get into it, but in order to retrieve the outputs, what I'm doing is you have to create an output key pair for each one. So basic variable is obviously for basic variable. You have to tell it what's the type of output that you're going to be displaying. In this case, it was a string. And then you have to tell it what's the value that you're going to be referencing. And so I'm using the variables function to go ask for the value that's stored in the basic variable. Good, and it looks like that finished deploying. So the variable with copy, where I had a whole bunch of copies running inside a single variable, returns basically an object type. The multiple variables that I ran, where it created a bunch of different variables with the copy loop, returns an array of those variables. So you can reference one of those directly. So if I want to reference a single variable that was in that multi-copy, I can use the variables function to pull all the values, and then use the square brackets 1 to reference what would be the second element, because, you know, 0 indexing and all that, the second element that lives inside that array. So if I go down all the way through, here's my single variable object, and this is the second item that was created by that copy loop with Arthur and Zaphod safely stored within it. That is a great question. The use case that I saw an example for was about attaching a bunch of disks to VMs. So this would be a way to create disk names that you want associated with the disk objects you're creating, and then just iterate disk 1, 2, 3, 4, 5. And then if you're creating 5 VMs and each one needs 5 disks associated with it, now I have a variable that has all the disk names stored in it with the VM name prepended to the disk name. So it was a bit of a stretch, but I think the guy who created this at Microsoft was really pumped about it. And so he came up with these examples, and I was like, wow, it took me a while to wrap my brain around it, so I just wanted to kind of bring that out. So that the real world use cases could be, I'm sure they're out there when you start getting to really complicated templates, but in something that's very simple, it probably seems like overkill. Yes?
My use, I think of this for release management, right? You know, I could script something, I can have it with source control, I can have it be part of release management, so I can go and if I need something that's like patch tests, right? Or anything else in the management environment. It's something that you can track, something that's auditable, you know, something that's QA-able, and something that you know is not release management.
Right.
Resource management.
Right.
You know, that seems to be
Yeah, and that's a great point about the templates. Just overall is the fact that they can be checked into source control and versioned. So anything you store in there, you'll be able to track deployments of and find out what the template looked like at the time that the deployment happened.
So you've got a combination of your templates.
Right. To sort of sum up that sentiment, the idea is, couldn't you just script out ahead of time what those values should be and submit them to the template rather than trying to use some weird process inside the template to generate the values? Is that kind of... I totally get that, and one of the things that some of the developers that I work with have struggled with is, at what point do I script versus try to put it in the logic in a template? Because the logic can start getting really convoluted if you're trying to put it all in the template. I can see arguments for both ways, and I think part of it is just like whatever you're most comfortable with, right? So just to get back to the presentation real quick. You saw a few functions that I used to get the variables, to get the parameters, and to do some concatenation. There are a ton of functions out there. If you want to see the full list of functions, go to aka.ms/armfunctions. That will give you the whole list of functions that exist. I'm not going to try to run through all of them right now. Just to give you an idea of the sort of grouping of functions, there's functions that deal with arrays and objects, functions for comparison purposes, functions that involve your deployment, and you already saw I used the parameters and variables functions to get values that are stored in those two types. Logical is all about conditional statements. Numeric is obviously dealing with numbers. The one important one there is copy index. So copy index is the function when you're in that copy loop and you want to find out what iteration of that copy loop am I in. The copy index argument, if it knows what copy loop it's in, it'll just return the number. If it's not sure, you can tell it what the name of the copy loop is, and it'll tell you what iteration it's in. Because you can actually have a copy loop inside a copy loop, which, you know, that's always fun to try to figure out. And then lastly, the resource. What's good about this is resource will return back the name of the current resource group that you're doing your deployment in. And it can also return resource IDs. So if one resource needs to reference another resource and you need the full resource ID of it, resource ID is your best friend for that. And then lastly, the standard string stuff. So being able to concatenate, split, contains. The one thing that I wish was in here, and I guess this would be a numeric thing, is there's no built-in functions for dealing with IP addressing. I would really like that. So if anybody from Microsoft is listening, I think I already put in user voice, but yeah, I'd really I'd like that because IP addresses are a beast to try to deal with. So we ran through variables, functions. So this was a fun one because I didn't know this existed until I started creating this. So I do want to run through this real quick. So parameters, again, I've got a parameter here that is a string. I've got a loop count in here, and then I've skipped down to the functions section. The way that functions work is first you have to define a namespace for your function. So how are you going to invoke that function later on your template? You need to be able to reference it. The namespace is how you reference that function. And then within the members section of this, you contain all the different functions you want to define. So I'm defining a function here called unique names. What does a function need? You need to be able to pass it arguments. In this case, they call parameters. And I am passing a single argument to the function called name prefix. And then I'm telling it, what should I return? What's my output, to use the verbiage of ARM templates? The output, I want to output or return a string from this function. And that string has a value where I'm going to concatenate whatever's in the name prefix parameter, and that's the parameter that I defined here, not the parameters all the way at the top of the template. And I want to add a unique string using the unique string function that's based off of the resource group's ID. So each time you run this, you'll get a new unique string that you could use. This is really good if you're trying to create storage accounts in Azure. You know those need to be globally unique. This would be a way that you could get that globally unique storage account name. I created another function called assigned array just to show that you can pass back more than just a string. So in this case, I'm still taking a single parameter, but the output is an array. And in this example, I'm passing back an array of disk names. So again, going back to the VM needs multiple disks attached. This could be another way you could generate that. And you can use it to create really complex objects as well. So I created a function called complex object that takes 3 parameters, and the output is basically a whole VNet configuration. So I pump in a couple things and I get out a whole VNet configuration. If I'm creating 4 VNets within this resource manager deployment, I now have a function that'll generate all the information I need to supply to each VNet that I'm deploying. So that's that was one use of the function that I was like, oh, I would legitimately use this for that. So again, I just included all the outputs in here. So the way that I'm invoking the function to get the value for this output is the name of the namespace, which was azug, and then the name of the function, and then I have to pass it the parameters in order that they appear within the function. So there's not a named parameters as far as I can tell. So you just have to know what order they go in. Which hopefully if you're writing the template, you already know that. So I'm going to go ahead and run this real quick, assuming my copy and paste works the way I want. All right. And so while that is running, I'm going to skip back to the presentation. So in terms of template validation, you already kind of saw what the process was for that. I used test-Azure ARM resource group deployment. There's also some online tool sets that will validate templates for you outside of ARM. So you can always copy and paste your template in there and have whatever that is. And there's also some template visualizers that'll look at what you're doing in your template and sort of break it out in a more visual way if that's the way that makes sense for you. As far as interpreting errors, usually it's pretty straightforward, but sometimes it can get real weird. So there is a debug option in there, so you can get some more debug level logging when you're doing a template. So it'll tell you exactly what it's doing. The log location is mostly just sitting in Azure. And so when you do a deployment, it sort of logs everything it does as part of that deployment. So especially if the deployment fails, you can go into the Azure portal and look at all the steps of the deployment and see at what point in the deployment that it failed. And hopefully from there, there'll be enough clues that you can troubleshoot out what went wrong. The biggest problem I've run into is when the process hands off to something else. So I've spun up a VM and then I have a custom script that needs to run on that VM. That's not going to report all of its errors back to the Azure log. You actually need to connect into that VM and see where the custom script failed. So if you can embed some sort of logging with that custom script, that would be huge. And hopefully, good. Okay. Yes. I'm in VS Code. Aha! You don't know, so this is exciting. So you're very visual. I'm sure you're familiar with Visual Studio. So Visual Studio Code is a very stripped down version. It's something like if you've ever used Atom or Sublime for coding. It's basically a very stripped down editor that has a few extensions in it. And the install is, I don't know, 5 minutes. Yeah. Yeah, so the bottom here is the terminal. If you've ever used PowerShell ISE for developing PowerShell scripts, this is what a lot of the people have switched over from ISE to use this because it has some more robust features within it. Yes?
Yeah, so what I do, I manage hundreds of servers. Not like anything like this. All feature Windows. This is just a little utility, much like Notepad++. But you put that on all your servers, and it's XML, it does JSON, it does batch files, it does like almost anything you want to edit as a DevOps person.
15 minutes? Is that good? Right, so the only things I've installed at the moment is Azure Resource Manager tools and PowerShell. So that gives me all of the linting and suggested stuff, and it will do the autofill and all the things that you like about Visual Studio, but without the like 8 gig install.
It also supports source code.
It does. So if I don't have any changes right now, but if I make a simple change, let me just add like that and save it, it knows that this is part of my GitHub repository. I can commit that change and then do a sync. And it doesn't want to sync, I guess, because it's still... Right, so now it'll sync that, and I just made a commit to my GitHub. Yes. But now Microsoft's own GitHub, so you're just going to use GitHub for everything, right? That's how it works. Okay, so my functions all ran, and it was able to successfully create some pretty complicated objects. I'm not going to run through the whole thing. Oh, here we go. So it created that VNet object, which then I could reference all the various portions of if I was then deploying a VNet template. And since we're starting to get a little tight on time, I'm going to push through a couple other things. So in terms of design patterns when you're using templates, one of the first things you have to determine, is this something that I'm developing for internal use for a whole bunch of people within my company, or is this something that I'm going to publish out to the marketplace? Because that sort of changes your approach. For published stuff, you want to really put the guardrails on and lock down how that template is deployed, what the allowable options are, because you know somebody else is going to be deploying that you have no control over, and they can't come back and ask you when they put in an improper value. So bearing that in mind, one of the approaches is to have t-shirt sizes where you have like a small, medium, and large, and that might be the parameter, and then you'd use variables to say, if it's a small, that means all these different values occur. If it's a medium, I get these other values instead. But that's all obscured from the person deploying the template. All they know is if I want a small deployment, I get this level of performance. If I want a medium, I get this level. Linked and nested templates. So this is a really good way of sort of breaking apart your templates into reusable pieces. So if I click on that link, it'll take me to a picture, but essentially, I have an example that I'll bring up in a second where I have a master template that is really just invoking, it's creating a whole bunch of variables, and then it's invoking a VM template and a VNet template to create the VNet, and once that's finished, it'll create the VM inside the VNet. That VNet template, I can reuse that for deployments all across my organization since it has a pretty standard format. And same thing with the VM, I can invoke that multiple times as well. So if you're looking for that sort of reusable components and making things modular, then linked/nested templates are going to be your best friend. Good question. So the question was, where am I storing these templates? So you can, when you reference the template, generally you reference it by a URI. And so it could be in a storage account, and as part of the deployment, you can give it the artifact location and an artifact SAS token to get to that blob storage. Or you can just use a publicly available URL, which is what I'm doing in this case. Since this is all published up on GitHub, I can reference the child templates or the other templates just by going directly to the URI. And so let me just bring that up real quick. Yes, Tim.
Isn't there also a public repo for other stuff that's out there that you can use to kind of draw off of and make your own off of it, or?
Yeah. There's so there is, I think I mentioned it at the top, there is a whole bunch of quick start templates on GitHub that you can reference, and those don't change a lot, the basic ones at least. So you can always reference one of those as a link template as well. So just to give you a quick idea, this is my master template. Scroll down a little bit. And so within my master template, I've got a whole bunch of different parameters that I need to submit to it, a lot of which have predefined values. But the one thing that you're asking about, where do I get these, where do I get the links to the other templates? I've created an artifacts location value, and in that I've submitted the raw link to the nested templates. So it goes right up into the name, up into the folder that those templates are in. If I was using a SAS a location that required some sort of authentication, I could give it a SAS token to do the deployment, but I'm not. I'll skip sort of over the rest of it for the sake of time. The t-shirt size thing I talked about, so I have a VM size parameter in here, and based off of the VM size, small, medium, or large, translates to a specific VM size that I choose within the variables for the VM template. To get into the resources section of things, so I am creating a VNet, so I named it VNet deployment because I'm creative, and the type of resource I'm creating is a deployment, which allows me to then reference a template link. And so that I am concatenating the name of the artifacts location and the name of the template itself, vnet.json. So that will get that template that's published in GitHub. And then the parameters, I have to pass it all the parameters I want that template to use, many of which were just in the original parameter values. And then VM deployment goes the same way. The one thing that I'll say in here is that, is it in there? It's in there somewhere. Or maybe it's not. So there is a dependency mapping. It's in the VM one. Okay. So the two things I want to mention in here, I talked about how I'm submitting it a VM size of small, medium, and large. In the variables, I have this VM size key value pair object. So small corresponds to a standard D2 v3, medium to a D4, and standard to a D8 v3. I'm not going to go through the whole thing, but let me just launch this, and while it's running, we can jump into the portal and see what's going on there. So I'm going to submit that deployment, and I skipped a step. See, this is what happens when you rush. So one of the things that I need to submit as part of the deployment is the admin username and credentials for the VM. So I have to get those first. There we go. And then I'm going to create a template parameter object that has all the values I need to submit. Oh, no, that's the wrong one. See, I'm jumping around. Okay. There's my values I need to submit. And then we will do the linked resource group deployment, and it's angry with me. Oh, because I'm in the wrong folder. There we go. All right, so that has started to deploy. So if we bounce out to the portal itself, yeah, that's fine. I didn't do anything. And go into the AZUG resource group that I created. You'll see that there is a set of deployments in here. So the linked template is the master template that's deploying all the resources, and it invoked the VNet deployment to do that deployment. So if I looked inside the linked template, it's going to tell me the only thing I'm deploying in here is another template. If I go inside that deployment, I can see the actual resources that are, well, maybe if I back up to. If I go into the VNet deployment, I can see the actual resources that are being deployed. So it deployed a VNet. It's happy with that VNet. So once that finishes, it's going to go to the next template in the line, which is the VM deployment. We're not going to sit through and wait for that whole thing, but rest assured, it's going to sit there and create all the various resources that were defined within that template. And when everything's green, it'll report back to the master template that I deployed successfully, and then the master template messages back to you that all the templates deployed successfully. I think I had one thing left. We're going to skip conditions. So conditional logic does exist. You can use it. I highly recommend it. The last thing I wanted to show you is VSTS integration, which I have a link for, if I can find my mouse. I can't find my mouse. Okay. There we go. That works too. I'm glad that Chrome remembers things. Right. So what I did in here is I actually created a project within VSTS that is leveraging these templates. And I created a build definition here. This is probably something that you guys are fairly familiar with. If I want to edit it, you can kind of see what that build is comprised of. It's comprised of a single phase, which is this Azure deployment task. And in the Azure deployment task, I've already associated my Azure subscription with it. So it went through a whole prompting stage where it would ask me to log into Azure and give it permissions. And then the action is I'm going to create or update a resource group, which I'm calling it azug CI/CD. And then I have to tell it what's the name of my template and what are the parameters. And I did a template parameter override to give it a whole bunch of parameters. One of which was I had to define some variables in here. The admin password, obviously, that has to be a secret type because the object is secret string. So I have to pass it a secret string. So it would have been very unhappy if I hadn't done that. Once I pass all those parameters, then it's going to go ahead. I can queue up a build. Yay, build number 3 has been queued. And so that will submit out to a build agent to then go through the same exact deployment process that is happening that I ran manually. This is the sort of thing where you could create something that kicks off the build every time you check in code. So every time you make updates to the template, you could have it automatically kick off something. I don't think I'm going to have time to show it, but if I wanted to change the VM size from small to medium, I could update the parameters. Actually, a better example is if I decided that small now needed to be a bigger VM, I could update the template with a bigger VM value, check that into source control, and that could potentially kick off a build that would replace the existing VM size with the new VM size. What would actually happen in Azure is, yes, it would shut down the VM, but it wouldn't delete it. It would just change the size of that VM and fire it back up. So in a real world situation, you'd want them in some sort of highly available set so you're not taking down your whole thing. But that could be a way to say, everyone who's using this template now needs to upgrade to this new VM type or VM size. Yes, Tim?
What do you recommend to use? So we've got our ARM templates and we start checking them in, and now we've got a bunch. And now I want to manage a larger amount of things in Azure. What is your recommendation for doing this part here, doing the CI/CD, checking in the code, and then having an idea of what is going on in Azure? Is it this line of tools? Would you consider looking at Terraform? Kind of how would you approach?
Sort of like how would you keep an inventory of everything that's going on?
How'd you get an idea of what's going on?
Yeah, because chances are the way that you're going to build this out is you're going to have some sort of base layer of infrastructure, which should probably be its own code and its own repository where you're building any VNets, storage accounts, those types of things to support your applications. And then your applications are going to be their own sort of deployment bucket that leverage those existing resources. So being able to track them all, I mean, part of it is just segmenting out your team so their blast radius is relatively small when they deploy resources, and kind of putting them either in their own resource group or subscription, because you can leverage resources across subscriptions. So that could be one way of kind of keeping your arms around what's going on. Another good way is to just log into the Azure portal and start going through and mapping out. There are some visualization tools that'll map out everything that's in a resource group or everything that's in a subscription. So you could use those to kind of get an idea of what you're doing. And oddly enough, cost tracking tools give you a really good idea of what's going on in Azure, because that's kind of their job. So cost is kind of huge. Yes?
Questions. One performance and second password. So for passwords, when we're doing this, every as a variable stops before the password in, which is crap. It slows me down, right? So then I start using fluids. But
Okay.
Is there a way to use key vault or something to pull a password?
Yes. Yes, so in VSTS, you can store passwords or whatever secret values you want in Key Vault. You have to give the VSTS subscription or some sort of build agent permissions to read the values out of that Key Vault. So there are some permissions you have to set up there, but then it can retrieve that secret and drop it into whatever deployment you're using. And I think that functionality is just built right into VSTS. See, Tim knows.
Running under Cloud Shell, PowerShell, using templates, scripts. Is there a faster way? And some of my scripts take 20 minutes. Cloud, keep their managements and so on services. Is there a fast way? Am I doing it wrong? Is that about right? Are there faster ways? What's the fastest way to do a script?
A lot of it is, so the question is, what's the fastest way to get my scripts to deploy? And I think a lot of that has to do with how busy the resource manager is at that moment. So there's not necessarily like an express lane for resource manager. It's just, you submit it, and when it has time, it will get to your particular deployment. There might be ways that you can alter your script so it's doing less work on the resource manager side. Maybe you're doing some more work up front. But it would really be a matter of looking at that script and sort of picking apart where do things slow down, and is it something that I can optimize in terms of number of requests going to Azure.
So my client does worry about disaster recovery. I wrote scripts, so if something goes down, you can come someplace else. And I actually start breaking on parallels because it takes a while for these guys to spin up the database server. So I guess his concern is, well, if I go down, it comes to 5 to 30 minutes to come in. What do you recommend for disaster recovery?
Well, so that's a whole other conversation we could have about disaster recovery. So the question was largely around RPOs and RTOs, like how much time can you afford to be down and what data can you afford to lose for your service? That is a whole conversation, and a lot of it just comes down to how much are you willing to spend to have the correct amount of downtime. And we could go back and forth on that for a while. Yes?
You're scripting most of these things when you're running commands. They look to be synchronous, right?
Mm-hmm.
I think you're running here, run the command, it takes 2 minutes for your next command not to run. They're essentially an asynchronous version of this as well.
Some of the tasks within the template can be run in parallel. So when you're deploying resources, unless you've explicitly called out a dependency in your resources for the template, it will try to deploy those resources in parallel. Yes. So not in a script, so not using a PowerShell script, but using the ARM templates, anything that you don't, so if I'm creating 6 NICs for 3 VMs, it'll try to create all 6 of those NICs at once. There is a limitation. It'll throttle itself at a certain point, but it will try to create all of those in parallel. It's not necessarily serial. Now the VM, you probably create a dependency that says that NIC has to exist before the VM does, so the VM can attach it. So, okay, you're gonna have to wait on that. But the other thing is, so the copy loop has a parameter in there. You can tell if it's a serial loop or a parallel loop. So if you want to deploy a whole bunch of the same resource, you could do that in parallel using a copy loop, and you don't have to wait for each one to iterate through. Okay. And I'm being told that I got to wrap it up. So thank you, everyone, for all of the questions. I very much appreciate it. If you want to talk afterwards, I'm going to go with Tim to a bar somewhere, and I will answer questions until I can't. All right. Thank you, everybody. I appreciate it.
Thank you, Ned. For those watching on the stream, we are going to take just 1 second and we will switch over to Matt Whitman talking about Azure Databricks. So if you're online, hang tight. We're just going to switch for just a second and we'll be right back.
Nope. And this was here, too. I'm glad it was, because I don't have one of those. You have a loud? You got a mic? Okay, cool.
Okay. Spark and Azure. So my name is Matt Whitman. I'm a cloud solution architect here with Microsoft. Specifically focusing in advanced analytics and AI, so the data space on Azure and 100% on Azure. So my job is to go around to our customers. I have a dedicated set of customers, but what we do is we do proof of concept development, hands-on proof of concept development, architecture design sessions, really helping customers be successful in Azure, part of a customer success organization. So who here has used Spark or knows what Spark is? One? Who here is a data person? So we got one data two data person, two or three. So, so Spark, what we're going to talk about today is Databricks. So we're going to start off by quick overview of what options we have to run Spark, what Spark is, and then we're going to do kind of a 100 level tutorial on Databricks, how to run queries, how to visualize your data, and just get an overall general good sense of what Databricks can do in Azure. I am by no means a Spark expert, so good thing there's only one or two data people in here because I might not be able to answer some of those questions. So Spark on Azure. So we have a couple options if we wanted to do Spark on Azure, and I'll get into what Spark is. HD Insight, which is our Hadoop cluster. So Hadoop also has Spark capabilities as one of the components of a Hadoop system. Azure Databricks is what we're going to talk about today. We can run Spark on regular infrastructure as a service. So we stand up VMs and we install Cloudera or Hortonworks or MapR, and those are distributions that manage the ecosystem of Hadoop pieces for you. Hadoop is something that's it's a big data system that's very complex in the different versions and making different versions work together. So what these distributions like Hortonworks, Cloudera do is they take care of all the back-end work for you and make all the components of Hadoop work together. Databricks is just Spark, so it's not the other Hadoop components. It's not HDFS, which is the underlying storage infrastructure of Hadoop. It's not Hive or Pig or any of those animals that are part of the Hadoop infrastructure, if you're familiar with Hadoop. It's solely Spark, and Databricks folks are the original creators of Spark, so they know what they're doing. So HD Insight versus Databricks, we'll breeze through this eye chart real quick. Really, HD Insight, like I said, it's our Hadoop infrastructure, so Spark is part of that. If you have expertise in Hadoop already in your organization, maybe look toward that because it's something that's that can be easily integrated with existing open source Hadoop if you run that either on premises today or in Azure. Databricks, if you're really focused on data engineering, machine learning, quick access of interactive queries. The main differences between, since this is not a data crowd, Hadoop and Spark is Hadoop is very batch-like. There's some enhancements over the years of batch processing on Hadoop, but the general basic of where Hadoop started is MapReduce. So it's taking a batch, it's doing things in batch processing, and then above the Hadoop above the Hadoop ecosystem, there's different services like Hive, which is SQL. So you can write SQL syntax that generate that SQL is then converted to MapReduce and runs big data processing. So it's meant for petabytes of scale data. Spark is meant for big data as well. Can go definitely into the petabytes because it scales in a linear fashion. But what I generally tell people is, if you have in the hundreds of in the high gigs to hundreds of terabytes, Databricks would do very well. If you are into the petabytes of data, which is a lot of data, Databricks can handle it, but HD Insight and Spark, or HD Insight and Hive and Hadoop can probably outpace Spark. So, Spark overview. So the Spark ecosystem is comprised of Spark SQL, so writing interactive queries using what we all know is, I'm sure a lot of people in here know SQL syntax. So using SQL syntax, Spark machine learning for your data scientists, Spark streaming for bringing in real-time data and doing query processing over streaming data as it's coming in, and graph computations, GraphX. All of that is above the Spark engine. So the benefits over Hadoop, it's 100 times faster because it's doing a lot of the computation in memory. Hadoop, everything is on disk and it's pulling data over the wire, which is why it's so much slower. Spark or Databricks provides a unified engine and a unified API over top of over top of the Spark compute for your interactive queries, for your stream analytics, for your ML. Machine learning. So let me quickly jump over because these are the only slides I have. The rest of this stuff is going to be done in notebooks. So we're going to skip over this real quick and jump right into it. Well, it looks like I have one more. So background on Databricks. The company's not very old. They're the original creators of Apache Spark. Came from UC Berkeley, and they're by far the largest contributors to Spark. Obviously, because the founders are the original developers of Spark. But that's who Microsoft has teamed with to bring Azure Databricks. Azure Databricks, as it was previously, was run either on-prem or in AWS. And now Microsoft is teamed to bring a PaaS service. So it's not infrastructure as a service, it's a PaaS fully integrated service with many of the Azure data services. So it integrates it can be deployed through the portal, integrates with storage services like blob storage and data lake, integrates with Azure Active Directory, which is a big plus, integrates with SQL Data Warehouse, SQL Database, Cosmos DB, integrates with Event Hubs and Apache Kafka on HD Insight. So it integrates with many of the Azure services natively. So the Databricks space, we really want to focus on the data engineers, data scientists, and business analysts. It doesn't really require a PhD in machine learning or data science to do a lot of this stuff. Now, the data science piece when you're writing MLlib stuff, it definitely is it's very helpful. But the fact that all of this is integrated into a single notebook and you can see visualizations real time of your data, it makes data exploration a lot easier than if you were trying to write map-reduced Java language to do processing of your big data. You can use SQL queries, load this stuff into tables. I'm going to jump into what we have the most, since I only have, what, 45 minutes? 40 minutes? All right, so Databricks, it's not open here. Okay. So Databricks is launched through the portal, and you create the service, the resource in Azure, just like you create any other service. It prompts you for the name and some miscellaneous things. But what it deploys is a workspace. That's the only thing, and you access the workspace from a URL that it generates. So within the Azure portal, the only thing within the service in Azure, it says launch your workspace, and this is the workspace. So everything is done here, nothing is done in the Azure portal, separate. When you deploy Azure Databricks, what it does, it deploys this resource in your resource group that you specify, but then it creates a generic resource group. And within that generic resource group, within Azure, it deploys all your VMs for your cluster and all the VNets and all the infrastructure around the cluster. So within this portal, we have menus down the left-hand side. This is just the home page, or the main page. But within Databricks, we have this concept of workspaces. So our workspace is comprised of, and this is the nice thing, you can have a collaborative workspace between your whole team. So you can have your team all working on shared notebooks. Does anyone know what a notebook is, a Jupyter notebook? So Jupyter notebook is formerly known as IPython notebooks. They're notebooks where you have cells that you can write your code in, and they look like these. So it's multiple cell blocks where you can put inline comments, inline text, blocks that have code. This is just doing 1 + 1 here. But it's a place where, and we'll see more notebooks, it's a place where it's kind of developer friendly, write your code and put markup at the same time. And all your work can be done with a notebook. So you can have a collaborative environment where you can share notebooks across your team using Azure Active Directory. You can assign users to the workspace, and all the users can collaborate. Or you can have lockdown workspaces, so that each user can have their own workspace. But all users within a Databricks workspace share this cluster. The cluster is the X number of VMs that you want to spin up. I have a demo cluster here running, but when we create a cluster, there's two different types of clusters. There's a standard cluster and a serverless cluster. And within the standard cluster, you can specify the size of VMs. It's the same VMs that you spin up in Azure that you're familiar with. You specify a driver VM and worker VMs. Driver VM is basically the head node, the control node that specifies and that directs the work to be done across the worker nodes, and you can specify the minimum and maximum number of workers. And what Azure Databricks will do is when it realizes that it doesn't have enough compute power to process the jobs that you're processing, it'll scale up automatically till it reaches that max number of workers using auto scaling, and then back down when it doesn't need them. And it'll terminate if you want to terminate it at X number of minutes of inactivity. That's the standard cluster. The serverless cluster is actually a serverless shared architecture. So it's meant for very, very high number of concurrent users playing around in a playground where clusters are spun up using Azure Container Service behind the scenes very quickly. So when new resources are needed, things are spun up. it's a shared architecture versus a standard architecture where your VMs that you specify are put into your resource group that are put inside of your VNet that can be peered with your on-prem environment, that can be peered with another VNet, so it's locked down to you.
It says serverless, but still you can run it in Azure functions. So I don't understand why they're running serverless.
Well, there are. It's serverless in that you don't see the VMs. I mean, VMs are running behind the scenes and functions too. So they're container instances. True. It's a shared environment. So it spins up it spins up behind the scenes Azure Container Service with X number of VMs, and it's a shared environment. So a bunch of different Azure Databricks workspaces are sharing that set of resources. It's more of what you know as a PaaS service. Databricks is a managed PaaS service, but behind the scenes in a standard cluster, it gives you VMs, and you own those VMs, and you can put your security around. So I have a demo cluster created, and I'm going to walk through some stuff here. So talked about a lot of this. What is Azure Databricks? Oops. So this is what Microsoft, how Microsoft, from an architecture perspective, looks like. Azure Resource Manager, which we just learned about, deploys and manages the storage, compute, and network for Databricks. So within the container of Databricks, we have a Databricks workspace, and then our VNet and blob storage. So storage and compute are always separate with Databricks. So that's one of the great things about Databricks is that you don't have any ties to storage and compute. Everything is separate, so you can scale them independently. So a lot of this, and I can share this notebook with anybody who's interested. Please feel free to email me. I'll share my slides. A lot of this terminology we have already kind of touched on, but it has a lot of details in here around what notebooks are, what workspaces are. Within a notebook, each of those pages are notebooks, and each notebook is assigned a language, either Scala, Python, R, SQL. Are the main languages, and within a notebook there's a default language when you create the notebook, and then you can jump between languages within the same notebook. So if you're writing something where you're pulling in and creating a data frame in that we're familiar, if anyone's familiar with Python, if you're pulling in and creating a data frame, but in this case it's a Spark data frame, and if you're doing that in Scala or Python, you can then create a table in SQL and query your data like a SQL, like what we know of a SQL table. When you create SQL tables, they go into a database, and you can specify, you can create a database and put tables within a database. These are virtual. These are Hive tables. Hive is, it's metadata. That's all it is, and it points to the data that's sitting on storage. When you run. We'll talk about this, but all data is sitting on blob storage. The metadata for this stuff is on Azure SQL database. When that's spun up behind the scenes, you don't see that. When you run a job in Spark, it's going to pull the data from blob storage, and then cache that data in memory, depending on what you want to do, or it'll put it in a local SSD. If you've chosen VMs with SSD, you can put that data on that VM, so it's local to the VM, which makes it extremely fast. So within the Yep. But either I'll get to that. So coming down here, clusters. I'll answer your question in a bit. So within Databricks, you can have libraries, so you can import your into the workspace. You can import libraries, either Scala or Java jars. You have the tables, which is in that data menu over there. Clusters, which spin up clusters, and you can also have jobs, so you can automate this on a daily basis to run your processes. The Spark architecture is something like this, where you have a driver, you have a head node, and you have your worker nodes. And each of those worker nodes, when your job comes in, it identifies a slot that's open on one of the executors, the worker nodes, and it'll send that task there. Here, interfaces. So to answer your question, each of these are APIs within the Spark environment. So originally, the original API was an RDD. And the RDD was an abstraction of data on your disks, and it's the API that's integrated across the different Spark machine learning and Spark streaming, different parts of Apache Spark. In later versions of Spark, it's become known as the data frame, which has some benefits and added benefits of and improvements, and now it's called the data set. It's the newest distribution of the collection of, and it's a combination of data frames and RDDs. So a lot of the work that we'll see in a lot of my notebooks, it's using data frames, but you can cache these data frames using a particular .cache syntax, and it'll cache whatever is in that data frame into memory, or you can cache it to an SSD, depending on use cases and how much data you actually want to cache. Now, if you have hundreds of or multiple gigs of data that you want to cache, you're going to probably put that on SSD and not in memory. We talked about the two different types of clusters, the serverless, etc. Let's jump over to the next one here. So when we work with Databricks, the first thing we have to do is mount storage. Storage is always in Azure Storage or Data Lake. I wish I could scroll with my finger on this thing. So to connect to Azure Storage, there's two ways. One of the most common ways is mounting it to your local VMs. So by running this command, we're going to mount the file system of this blob storage account to mount/training courses. So when you run execute jobs, it's Control-Enter or Shift-Enter, and it will execute that job. And you can see this one was already mounted, so it didn't do anything. Within the query language has this by doing %fs or %SQL or %Python or %Scala, you can indicate what language you want each cell to run. So here we're going to actually just run an ls on the directory. We can see we have two paths in here. We can quickly and we're doing this straight from storage. So this is sitting on Azure Blob Storage like that. We can do a head and quickly see what. Well, this one was removed, so that's a bad example. We'll move down here. The head will just grab the first couple rows from the file. Actually, we're going to jump on to the next one. The next one is about reading the files. So that's that. Once we have storage account mounted, we can then go and pull the data into our data frames in Spark. Yep. 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 And then if you can automate those You know, this environment and notebooks is great for interactivity with your data, exploring your data, learning your data. Think of it as the early stage of your machine learning or AI advanced analytics process is learning about your data, because you can see visualizations and charts right in line of what you're working on. So this is what a typical architecture kind of would look like. So we have raw streaming data coming in using a streaming queuing service like Event Hubs or Kafka, streaming into Databricks, which is our Spark streaming solution. That Spark streaming solution is going to pull that data in that's probably coming in as a CSV or a JSON format, and converting it to Parquet, because Parquet is the optimal storage format for Spark. Parquet includes the schema and the data all in one package instead of having to specify schema. It's all there. It's a lot faster. Down here we have our batch processes. And this is just showing the different interactive or serverless. For serverless, because it's quick and it can spin up servers independently, you can use that for real-time analytics and connecting to Power BI through JDBC connections. And then interactive, doing machine learning and exporting to any other Azure service. So reading and writing data files. So the first thing we're going to do is we're going to take a look at this product.csv file here. A head command is going to show us the top data, and you can see it's in CSV format here. So this is what a typical data exploration process is going to start, right? You can point to a single file, or you can point to a directory full of CSVs, and it'll pull them all. Assuming they're the same format, it'll pull them all. You can pull them all. You can read, so reading the CSV into a data frame, you can pull it into, you can just do a .csv and it pulls it very quickly. So there's there's transformations and there's actions in Spark. Transformations are what I just did. Didn't actually run a Spark job because it just prepped it. When I do a .show or display, it'll actually run the job. So that's how Spark makes things so quickly. It's the pipeline of processes where it builds up the processes of transformations along the way, and then when you actually do an action, like show it or display it or query it, it'll that time distribute that query across X number of nodes that you've set your Spark environment up, and process that node across in a distributed fashion. So, so we can display our data real quick with this display, and we can see we have no headers in the first line. The first row was the headers, so we just read it in as is. So we can quickly say, okay, the schema, the way that read in, we didn't read in a schema, it was a CS file. We can see the schema are all strings. So we can have Databricks infer the schema. So we can say the first line's a header, and we want to infer the schema, and point to that CSV, and it'll actually come back, and by printing the schema, we see that it has identified the columns that are in that CSV as integers, strings, and doubles. We can then display that data frame, and we can view that data frame in a chart or as raw text. So we have raw text here. You can see the headers are now in the header fields. The columns are now set to their appropriate data types, and we can do real-time visualizations over that data by using this chart feature. And we can go into plot options. So there's multiple different plot types that you can plot. We can come in here and we can change around and say, okay, instead of price, I want to see, I want to see size. Sorry. And what this does is it does a sampling. So it's not actually graphing all your data at this time. It's doing a sample, so you can visualize your data and get a sense of what you're dealing with. We can infer the schema with SQL. So now this is our what we know of a SQL form. What everyone knows of how to write SQL queries. We can do create or replace. We can create views, tables, etc. in our database straight from blob storage. So it's going to point this to blob storage. It's not actually inserting any data into the database because the database isn't a true physical database, but it's pointing this to this file. And now we can do a select star using SQL over that same exact data instead of using Python. So we can use R, we can use Python, SQL, or Scala to do the same exact thing. We can do our where clauses, our group bys. Transformations and actions is what I mentioned earlier. Transformations are those selects, distincts, group by sums, but actions are actually when it submits the job to the cluster. We can also, instead of inferring the schema, because inferring the schema is very expensive, especially when you have a lot of data, because it's going to read through all the data, you can specify the schema format up front, and then refer to that schema when pulling in your data frame. So this is doing the same thing, much quicker. I don't have to run this again. We can create views in our database by saying dataframe.create or replace temp view, naming that temp view. So now when I do show tables in SQL, we can see products df there as, and it is a temporary table because I created temporary view. Temporary views will go away after the notebook session ends, or you can create a table that'll persist there. Different SQL queries we can run there. So this gets you an idea of how to query, show the tables. You can read from CSV using the user-defined schema straight to SQL, so you don't have to deal with Python if you don't want to deal with Python. Before, we were reading it into a Python data frame or a Spark data frame using Python. Here we can do the same exact thing all in SQL. Let's go down here. We can even go from a SQL table back to a data frame by doing this, and then we can use Python to do the same type of thing. So that's all doing things against CSV, and it's not very efficient for CSV. It's multiple factors quicker by using Parquet. So typically when data comes in, we're going to bring it into SQL. We're going to then store it as a Parquet file. So to do that, we're going to take this data frame, this as a sample here, product df, right? And we're going to do a collect on it, which we've already done because so a collect submits the job. If I had just created this data frame and pointed to a CSV file, it wouldn't have collected the data yet into the data frame. By doing a collect, we're going to actually do that action and collect that data. And then once we have that data frame, we can change it to a pandas Python data frame. This isn't required for the Parquet. This is just showing how you can make it a pandas data frame. And then you can query it. You can use regular Python. It's called PySpark, but you can use Python to manipulate and do whatever you want. So this comes in handy when you're doing machine learning and you already have a script in Python. You can do all your Python coding straight in here also. Here we can write that data frame, product df, with one partition to Parquet. And you can specify X number of partitions. You can say, I want to partition by a certain field, and all that stuff is going to optimize your performance depending on your query. what queries you need to run. But by doing that, what we did was we just wrote this file out, products.parquet. And you can see our Parquet file is in our file system now with a couple different files here. If this was a partitioned in multiple partitions, we would actually see multiple different a lot of different files here if it was very large, but this file is like 40 records, so we're not seeing all that. And then we can now read our Parquet file and operate exactly like we did against CSV. You're not going to see the performance difference because this was 40 records. But the next file, the next notebook that I have, is going to demonstrate that difference in performance. So here, it's the same exact thing, writing to Parquet using SQL. Writing to SQL using Parquet. And that's all I have for this. So that sample set was only 40 records. If anyone's familiar with the New York City taxi database data set, if you're into machine learning, it's a very popular data set of all taxi trips and fares. I think the trip set alone is 700 million records. So we're going to process that, and we're going to show the difference between if I'm reading that into CSV via CSV and putting that on SSD, and it's significantly faster. I won't run the CSV piece, but I think it's in my notebook of how long it took when I did do this. So what we have the two different cache things we can do is cache into memory, which is using the .cache. So if you take your data frame .cache, it's going to cache that data frame into memory. Or you can use what they call a DBIO cache. A DBIO cache requires some parameters to be set up front on your cluster. But when those parameters are set, if you're working with any Parquet file by default, it needs to be Parquet, it's going to cache that data frame into SSD across your distributed cluster. So you're now eliminating the need to pull that data across the wire every time. No, it'll put the data on the SSDs that it has available and put the rest in storage. It won't scale your cluster by sheerly because it doesn't have enough SSD. It'll scale your cluster based upon resources of compute. But this is something that you would know before you go create your cluster. How big of a data set you're working with. Do you want to? What type of queries are you running? Do you need to have all that data in SSD at one time? So Spark is a lot of the stuff with Spark is you're playing around to learn about your data, but when you're ready to actually do something or automate or make a job out of it, what are you going to ask of it? What type of queries are you going to run? It's going to help you determine how to partition your data, whether to use RAM cache versus SSD cache. A typical data analyst, not data scientist, a data analyst would use this. I wouldn't, I don't know if there's a minimum size of data that I would say don't use this for, but I really like the fact that you can infer schema and not have to deal with that. You can create a cluster that's just 2 VMs, 2 worker nodes and 1 head node, and explore the data and visualize it with, we were doing this with 40 records. So it's still fast on 40 records, but it'll scale linearly. So if you're doing this on, my node right now, my cluster, I think I have 5 nodes, and it did aggregates over 700 million records in 20 seconds on 5 nodes. And this, you can scale this to hundreds or thousands of nodes. So this trip data, well, it's nope, it's the same cost as any VM per hour. So if you want to go explore 100 nodes worth of data for 2 hours, you're going to pay for 100 nodes for 2 hours.
But also remember, if you're reading the thing and having the data for the cluster definition, it said X number 5 cents per data person. That's up to I would spend $1,000.
Databricks licensing fees on Azure. On Azure?
It's AWS, but
Okay.
still, I'm not about the same compute.
Yeah.
I mean, if you're doing
Well-
serious data analysis, machine learning, it can add up.
And if you're doing serious analysis, think of this as analysis versus doing like deep learning training on a Azure machine learning database, right? Or a big data set. If you're doing training for a machine learning model, maybe this isn't the best route. I would use something like Azure Batch to do just straight up training. But if you're exploring the early stages of the analytics, this is great. You can once your model is trained, using this at 50 cents per DBU times the number of nodes. If it's for an hour, it's 50 cents times 100, so $50 for an hour. Typically, you're not training for 24 hours a day for a training model, so it'd scale back down. So this particular data set, I think it was like 60. I don't know. It was like 60 or 70 gigs. I think it wasn't very big, but it's 700 million records. So this particular thing, let's see if it's in here pointing to the right place. Yep. All right. So this is for all the trip data for a particular year in New York City, or at least from that GitHub repository. We're going to load that into SQL using in a CSV format. So we specify the schema just to help it be quicker. Did I do that? Yep. We're going to load this into a data frame. And we're going to show that we can show that data frame, but we're going to come down here. We're going to put it into a view in SQL, and you can see that view exists, and we can see this is how many records was in that table with CSV, and you see it took a minute 19. I'm not going to run this, so we don't have the time. But when I ran this, it took a minute just to get the count using CSV. We can do an aggregate, so basically taking the time and doing the count by pickup time by taxi ID. This one took 2 minutes and 20 seconds just to do that over 700 million records with 5 nodes. If we did the same thing using RDD cache, so basically taking that table and applying a cache to it, so it's the same thing as taking a data frame.cache, so it's caching in memory. That same query took 17 seconds, and now it's still over a CSV. It's cached, but it's still using a CSV format. So now we're going to convert that CSV to Parquet. So we're going to take that. I'm not going to run this. It took 2 minutes to convert it from CSV to Parquet, and then you can enable and disable the IO cache. So IO cache is loading this to SSD. So you can enable SSD here. You can see it's false to start. Well, it's probably true now. let's make it false because it's true by default. So right now it should be false. And reading that Parquet file takes 1 second. It was probably already cached. But either we can see my other numbers here. The problem with Parquet is that by default it's already SSD enabled by default. So as soon as you load that Parquet file, it automatically puts an SSD. So without carefully playing around with this and running them in the correct order, it's gonna cache them in SSD. But ultimately, we took that. Here's that query file without the Parquet file, using Parquet but without the DBIO cache, so it's not cached. It took a minute 70 seconds to run, but using with the Parquet on, doing that same exact aggregate took 50 seconds. So half the time doing a full aggregate over 700 million records with the data on local SSD. So there's differences in performance between the two. I'm going to stop here because I know we're short on time. Does anyone have any questions? No? I think 4 worker nodes. 5. Of how many? They're small. They're DS3s, I think. So it uses the enhanced networking that we have. Yep.
So you said Databricks is basically, but it's based off of Spark technology.
Big is in multi-petabytes, yes.
Yes. So is Databricks being received building it up?
Well, the reason it's not faster for petabytes of data is because this is doing stuff in memory, and when you have that large scale of data, you can't do that. I think personally, I think Databricks is probably one of the better, and I think the popularity, it's new, but I think the popularity of Databricks is really going to take off, just because you can do everything in one thing, right? Before you needed to have event hubs, stream analytics, machine learning, all the pieces, you had to glue them together to do in a scenario. Here you can have Python knowledge and do it end to end. Well, from the machine learning perspective, you still need a data scientist because you're writing machine learning. It's not like Azure Machine Learning Studio where you can just drag and drop things.
Yeah, but a lot of these things are repetitive. So
Sure.
the data will change over time. Let's say set up a workflow.
For exploration of data, yes, you can give it to a less experienced person. For developing machine learning models, you still need a data scientist to go, in my opinion. Yeah.
The data that's appropriate to run through Spark is things that you can pass up and parallelize, correct? That otherwise know that they were small streamable chunks of the process.
it processes it. The concept is very similar to Hadoop. It's still a map reduce like process behind the scenes, but it does it in memory and uses a different pipeline to do it. So it'll do a map reduce like function in memory and store a result in memory and use that result at the next stage, and it builds this pipeline up in memory for what Spark does until you call it, and it'll execute all of them in sequence. But MapReduce is more of a batch. It's meant for batch processes, unless you do things like Interactive Hive. So what Interactive Hive is SQL, but it's more interactive, and you can do things more interactive like you can in Spark with Interactive Hive in HD Insight or Hadoop in general. Is that all the time we have? Thank you.
Good. Thanks so much.